Hi, this is Mr. V, and would you look at this monster of an expression I've got. It's very complex, it's got lots of different index laws involved, and we're going to try and solve that one. So we're going to try and simplify an expression that involves multiple complex applications of the index laws. Alright, where do we start when we have a big monster such as this one? Now there's a couple of different strategies you can take. You could group everything alphabetically. So group all together all of the numbers, group together all of the A, all of the B, all of the C's, all of the X's, solve each part separately, and then just merge at the end. Or we take this index law after index law. Now I'm going to take this index law by index law, but either strategy would work. Index law by index law. So this means we're gonna kind of cover up the parts we don't worry about until we do want to worry about them. So everything we worry about, I'm going to put in my blue pen, and I'm going to start by solving this part. Okay, the part of this expression where we're multiplying. So if we kind of turn a blind eye to everything else, and we just solve this. Right, let's start. Now, within this index law, our strategy has always been to group and solve. So I'll rewrite just this component here. So 3 times 4 times a times a to the power of 3 times b squared times c cubed times x to the power of 5. Now I'll put in the rest of the working in a second, but I want you to focus on just this part. So I'll leave a bit of space here. Now let's tackle each part separately. So 3 times 4 is 12. A times a cubed, well, there's an invisible 1 on top of this a. A1 times a3, add the powers, that's going to be a4. We've only got one b, so I'll leave that. We've only got one c, so I'll leave that. And I've only got one x, so I'll leave that. And just to take up less space, I'll rewrite that once more. Alright, so we ignored all the other stuff going on. Now we're going to have to bring it back. So I'm going to have to do a bit of writing here, because I do want to show all of my working. And I'll put this in black. So in black is all of the stuff that we didn't touch. So we're just going to copy that straight from the question. 6a4c6x4. Copy that in here. 6a4c6x4 squared. And once more, 6a4c6x4 to the power of 2. Right. Again, I will tackle just the part we're interested in, and then I'll rewrite in everything else. So I'm going to now solve this fraction here. So equals, and again, I'll start by grouping. So 12 divided by 6. There are numbers. We've got a couple of a factors, so a4 divided by a4. Put a dot in between to signify times. Dot. I've got b squared and no b factors on the bottom, so I'll just not worry. Dot. So times c3 over c6 and we've got two x values as well. We've got x5 over x4. And I won't write in the rest yet. Step by step. 12 divided by 6 is 2. Times a to the power of 4 divided by a to the power of 4 is a to the power of 0. 4 minus 4 is 0. Dot b squared, untouched. c3 divided by c6. 3 minus 6 is negative 3. So I've got c to the power of negative 3. Dot times x to the power of 5 divided by x to the power of 4. So x 5 minus 4 is 1, so to the power of 1. Now I've got a few instances here where I can use my 4th, 5th, and 6th index laws. So I'll tackle that. 2 stays. A to the power of 0 is 1, and 2 times 1 is 2, so it just kind of vanishes. b squared, c to the power of negative 3 is the same as 1 over c to the power of 3, so I can put that in the denominator of this expression, the c3. So this negative 3 just puts it onto the bottom, onto the denominator. And x to the power of 1, I can not write in the power of 1, so that's fine. Not quite done yet, because we still had this to the power of 2. So again, I'll rewrite it in black. So to the power of 2, to the power of 2, to the power of 2. Alright, now we'll take care of the squared. Equals 2 to the power of 2 times b to the power of 2 to the power of 2 times x to the power of 2 divided by c3 to the power of 2. And I can just fit it onto this page. 2 squared is 4. b squared squared, so 2 to the power of 2, we can simplify that by multiplying, so b 4 x squared, nothing to do there, divided by c cubed squared, so 3 to the power of 2, we can multiply those to simplify, so that's going to be c to the power of 6. And that is how we solve an absolute monster of an expression involving multiple complex applications of the index laws. Well done.